This is section 12.4, finding sums for infinite geometric series. We're first going to start with the sum Sn for the first n terms of an infinite series is called partial sums. The partial sums of an infinite geometric series may approach a limiting value, very much like an asymptote. Here we're going to consider the numbers 1/2, 1/4, 1/8, and so forth. We're going to add those together. When we're looking for the partial sums, this is typically in a graph. And we're going to take, for the first term, we'll take our half. For the second term, our second partial sum, we're going to take the first and second number added together. For the third partial sum, we're going to take the first three numbers added together. For the fourth partial sum, the first four numbers added together. And for the fifth partial sum, it would be all five numbers added together, and so forth, the sixth, the seventh, the eighth. And as you would graph that out, you would notice that the values are going to approach a certain maximum. And that value is going to be what's called the partial sums, which is your S of n number. It's a way to represent an infinite number of values adding together, and it'll have a maximum value, very much like an asymptote. S of n seems to approach one, 0.4, 0.6, 0.8. It's approaching the number 1 as n increases. So on review here, partial sums, if you're asked to find the partial sums, you take the first number, and then you take the first two numbers and add them together, and then you take the first three numbers and add them together, the first four numbers and add them, and the first five numbers and add them. And you could continue that with the sixth and seventh, and you'll see that it does approach a value. The value of partial sums is called the sum of the infinite geometric series. This sum can be calculated as long as a common ratio has an absolute value less than 1. We say absolute value because the ratio could be positive or negative. We're not concerned about its sign. We just can't have the number bigger than plus or minus 1. The infinite geometric series has no sum because our partial sum would never approach a single value. Our arithmetic series wouldn't have an infinite sum because the numbers would continually get bigger and bigger and bigger as you would plot it out. But if you notice here, we're going up by 0.5, and then we go up by 0.4, and then we go up by 0.12. We're going up by less and less every time. Therefore, it's going to start to max out on what height it can actually get. Even if you just kept adding the halves on more and more and more and more, you would never reach 1. It would get close to 1, but it would never reach 1, so we call that the maximum value that this series can reach. Therefore, its sum would be 1. There's a formula that we can use to calculate an infinite geometric series. We take the first term, we're going to divide it by 1 minus the ratio. Notice right here, kind of highlight this portion of it. If r is greater than 1, then it has no sum. If the ratio is 2 or 3, even 1.5, then the numbers are getting bigger every time, and you couldn't find the sum of that series. Here, for the first problem, we see that the ratio is 0.8, so it's less than 1. Our formula is 1 minus r. The first term is 0.8, 1 minus 1. So that's 0.8 to the 0 power, which is 1. The ratio is, of course, 0.8. So the sum is 1 over 1 minus 0.8. 1 over 0.2, which is a value of 5. Here we have a series. We can test to see if it's geometric. If you take your negative 3/4 and divide it by the one before that, the answer would be negative 3/4. Take your 9/16, divide it by your negative 3/4. To do that, you're going to multiply by the reciprocal. This would get us negative 36 over 18. 9 goes into, let's see, that goes in there 2 times. That was actually 9 over 16, which was 48, which was still negative 3/4. And if you keep recognizing with the same test, we're testing for geometric, that our ratio was negative 3/4. Okay? Our first term is clearly 1. So our sum is going to be 1 over 1 minus negative 3/4, which is 1 over. Here we'd have 4/4. This would be plusing 3/4, which gives us 1 over 7/4. And when you're dealing with a fraction in a fraction, you multiply by the reciprocal, so you have the answer of 4/7. That was a tricky one. But notice how the ratio is negative. When you multiply it the first time, you get a negative. When you multiply a negative by a negative, you get a positive. And it alternates back and forth, positive, negative, positive, negative. The partial sums would still be approaching a value. Here, our first term is clearly 3. Our ratio is 5/4. But because 5/4 is greater than 1, we have no sum. Remember that the ratio for an infinite geometric series has to have an r value that is closer to 0. It's between negative 1 and 1. Sometimes we call that the absolute value of 1. It has to be less than 1 for it to have a sum. It has to be between negative 1 and 1. Here, To calculate our first term, notice how the first term would be in front of the parentheses, but even if you don't recognize that, you can plug a 1 in for n. One minus 1 is 0. Anything to the 0 power is 1. Your ratio is, of course, 1/2. The ratio is the value that's being raised to the power. The sum is going to be 1 over 1 minus negative 1/2, which gives us 1 over 1 plus 1/2, which is 3/2, which comes to 2/3. Here we have an infinite, because it has the infinity sign. We see that it's geometric. It's in our standard form with the first term, the ratio, and our exponent. But because the r value is greater than 1, we know that this is going to have no sum. Our first term is still -6. The r value still is there, but we can't find the sum. The numbers get bigger and bigger and bigger every time. Here we have our series. We're not quite sure what the ratio is yet. Some of you might recognize it, but let's talk about how we would figure it out. We would take our second term, divide it by the one before it, so then we have to multiply by the reciprocal, and we get 1/4. That by itself doesn't mean that much. So we have to try it again. See if we get it the second time. We take our 3/16 and we divide it by the one before it. So that's going to be our 3/16 times 4/3. And we could reduce. The 3's cross off, the 4 and the 16 reduce to become 1/4. So we can see that this ratio is also 1/4. The first term is clearly 3. Because the r value is between -1 and 1, we can find the sum. So we say 3 over 1 minus our ratio, which is 3 over 1 minus 1/4 is 3/4. And then to calculate that out, we say 3 times 4/3, and that of course would leave you with 4. So in review, for us to use this formula, we have to have a geometric series, and we can test for that. Test for geometric. It's really a geometric sequence. The test for a geometric sequence is a of n over a of n minus 1. Take a term, divide it by the one before it. So, it has to be geometric. The r value has to be between 1 and -1. Let's call that the ratio. Ratio between -1 and 1. We could show it like this. The R value has to be less than 1, but it has to be greater than -1. If we have a geometric series, remember, a sequence is a list of numbers with commas between them. A series is a list of numbers with plus signs or minus signs in between them. If it's a geometric infinite series and the R value is between -1 and 1, then we can still find its sum. On the next side of our notes, we're going to use this concept of an infinite geometric series. A person is given a push on a swing. On the first swing, the person travels a distance of 4 feet. On each successive swing, the person travels 75% of the distance of the previous swing. What is the total distance the person swings? So the person's going to only travel 75% of the previous swing. Mathematically, we could continue that on forever. It just goes on, and 75% of that number, and 75% of that number. We know with gravity and so forth that the swing is eventually going to stop. But for a while, the total distance can be calculated. We're going to start with 4. Then we're going to take 75% of 4. Then we're going to take 75% of that number. So I could write that as being squared. Now we have the 4, we have the 75, and then we have 75 again. So we're taking 75% of the previous number. Now we're going to take the 4, 75, and we're going to take 75% of the previous number again. And we could continue this on. Each swing is going to be 75% of the previous swing. So we notice that this number is 4. This number, if you use your calculators, of course 3. This one comes out to 2.25. And a calculator would definitely be needed for the next one. 1.6875. 1.266, and so forth. If you start adding the numbers up, if you add up the 4 plus 3, the 4 plus 3 plus 2.25, the 4 plus 3 plus 2.25, plus 1.6878, we're representing a partial sums. Remember, when you add up the different amounts, we could put it on a graph possibly. But here we're just looking for the total sum. So we don't have to worry about really the partial sums. We're just going to recognize that the first term is 4. The R value is 0.75. So to figure out our sum, we're going to take our first term over 1 minus 0.75, which leaves us with, when you take 0.75 away from 1, you get a quarter. which 4 times the reciprocal of that is 16, and this would be in feet. So mathematically, we would say the person swung 16 feet. Suppose the person travels 3 feet on the first swing. How does that change things up? Well, your first term would then be 3. Your R value is still 0.75. So your sum is going to be 3, 1 minus 0.75, which is 3 over a quarter, which is 3 times the reciprocal, which is 12 feet. Okay, the last question. A pendulum that is released by swinging freely travels 18 inches on the first swing. Back and forth. On each successive swing, the pendulum travels 80% of the distance of the previous swing. What is the total distance the pendulum swings? So on the first swing, this shows that it's going to travel 18 inches. On the second swing, it's going to travel 80% of that. On the third swing, it's going to travel 80% of that. So they have 0.8 squared, and then 0.8 cubed, and that would continue on and on and on, very similarly like we did up in example 3a. So you go ahead and calculate what the total sum would be. We know what the first term is. We know what the ratio is. So we just use our formula. To show that that would travel 90 inches.